Okay, we should all be on this page here. At the top, it says proofs with corresponding parts. So today, we're still proving stuff. Okay, that hasn't changed. The good news is I'm not really going to throw, what is that? How do I get that to go away? Just cancel. Oh, now it's gone. Okay. I'm not going to throw a ton of new stuff at you. Okay. There's only going to be one new piece of information that we need to talk about. And we're going to handle it right away. Because if you look down at like your proofs even, like look down here at these problems, look at the proof statements. Do those proof statements down below have triangles in them? They're talking about what? Angles and segments, like sides of triangles. Okay, so our proof statements look a little bit different because so far we've only seen the ones where they all said like triangle this is congruent to triangle this. Okay, so let's talk about why these are different and how do we handle this. Up here at number, or at the very top of your page, they're not numbered, but it says, what can we conclude about the corresponding parts of two triangles if we know that the triangles are congruent? So let me draw you a picture to illustrate what I'm talking about. Let's say I have those two triangles, okay? They look pretty close to being congruent. And let's say that they gave me some markings. Like that. If that was what was marked on your triangles, would you be able to say that they're congruent to each other? Yeah, because what of the 5 tests does it satisfy? SAS. It's working for side, angle, side right now. Okay? So here's the question that they're asking. If you know that those two triangles are congruent, what's true then about all the unmarked pieces? They should be congruent too. Because if we know these two triangles are congruent, that means that they match. Everything about them should have like a partner to pair up with. So what I'm talking about is like this angle here, for example, and this angle here. Those aren't marked right now. But if I know that the triangles are congruent, I should be able to add markings to them at this point if I felt like it. And the same thing goes with sides. If sides aren't marked, I should now be able to mark them up because we know that the triangles are congruent. What this is called, and like what we refer to this as in geometry, is this really big phrase. Okay, so we're going to write it down, and then I'm going to give you guys a way to remember it. Here's the phrase: corresponding parts of congruent triangles are congruent. It's kind of a mouthful. It's a lot of words, okay? So because we have a lot of words, we have a way to kind of abbreviate this. Like we have an acronym that we can use to represent this. Just like you've had abbreviations for your tests. Instead of writing out the words side, 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 or side, angle, side, we used letters. SSS, SAS, ASA, like we had all of those. We also have an abbreviation for this. Okay, and here's what it is. It's C, P, C, T, C. And here's where those letters come from. We take the C from the corresponding, P from parts, C from the first congruent, T from triangles, and the last C comes from that last congruent. Okay, so how are we going to remember this? Now, it's a lot of letters, and, you know, like side, angle, side, and that kind of stuff, like those tests are maybe easier to remember because it makes sense that like S would be sides and A would be angles for triangles. But this has a little bit more letters, and there's a lot of C's here, okay? So you can kind of maybe come up with something that works for you. You know, if you have like colors that you're thinking about that you would want to put in for the C, the P, and the T, or if you have favorite drinks or like something like that that you really think about a lot, games, movies, something like that. I'm going to show you guys a picture here that a former student created. Not a former student of mine. This has been passed down to me. Okay, but this is actually created by someone who currently teaches at this school. Do any of you know Mr. Kluver? A couple of you do? Okay, he made this. So when he was a sophomore, just like some of you guys are, in his geometry class with Mr. VK, they talked about this same property, CPCTC. And they tried to come up with a way that they could remember it, okay? And he had the students kind of come up with their own thing, and then this kind of was a product of that. So Mr. Kluver, if you guys know who that is, he came up with this, and it says corn, potatoes, chicken, tomatoes, chicken. That's how he remembers this, okay? And I've been told that Mr. VK asked him, why do you have chicken on here twice? And Mr. Kluver's response was, because he really likes chicken. So if you guys know Mr. Kluver, maybe ask him if you see him today, hey, do you remember talking about that corn, potatoes, chicken stuff in geometry? Last year we had kids do that, and he kind of laughed because he's like, oh yeah, I remember doing that. So if you guys know him, maybe this will help you guys remember those letters a little bit. Now, if you don't want to use this, you don't have to. Okay, but I'm going to refer to this every once in a while. Like if I'm asking you guys to remember these letters and it's taking a little bit, I might start to say corn, potatoes, and then I want you guys to be like, oh yeah, chicken, tomatoes, chicken. Okay, and this is also, I'm just going to put it up here on the board so that we can just kind of think about it. And it's going to stay up here for the remainder of the unit so that we can just remember CPCTC as we're getting going with these proofs. This is the only new thing that we're going to add today. Okay, is every proof statement is going to look a little different than the ones that we've been seeing because they're not triangles anymore. They're these angles or these sides. And so we're going to have to end our proofs today with CPCTC. So we're going to get some practice in doing that. But down here it says, how do the prove statements differ from our previous proofs with triangles? We've kind of talked about that already. It doesn't have a triangle statement. It has sides or angles. And then what do we think we have to prove? We have to prove that the triangles are congruent first. So we still need to go towards one of those 5 tests. And then once we get there, we can tack on this last line of, okay, because those triangles are congruent, everything else about them should match. And these triangles then should work to have all congruent corresponding parts. So let's get into some examples here. We're going to start with this one, which actually looks really similar to our bell ringer today. So I'm hoping you guys haven't forgotten everything we talked about just a couple of minutes ago with that bell ringer, because this picture looks almost identical to that. We've got parallel sides. Those are marked with those little arrows. And we've got these congruent sides here. I want to be able to fill out the proof. Now, I want to start these the same way we've been doing our proofs. We want to get to one of those 5 tests. We want to get to side, 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 angle, angle, side. Whichever one works, we want to get to one of those first. So we're going to start by writing down our given. So let's all do that to begin with. The other thing is I would just double check. Do they have the pieces marked in the triangle that they're talking about? We have the arrows for those parallel lines. And if you notice, they do have the dashes already for us. Right here is that dash, and right here, I just went over it again in red. But those are already marked, so we don't really have to do that if we don't want to. All right, now we need to start looking for other things. What do you guys want to use? Alternate interior? Because we have parallel lines. So again, if you need to do this from yesterday, we've got these are my parallel lines. And then we're looking for a transversal. Where's the transversal at? B to C to D, or you said A to C to E. Okay, you could use either one. And honestly, we could use both if we really wanted to here. Let's start with B, C, D. If I just highlight that one. Where would the alternate interior angles be? B and D. So I'm going to go ahead and write that down. Angle B is congruent to angle D because of alternate interior angles. And I'm going to mark those. So B gets an arc and D gets an arc. Now, if we switch our transversal to the other one that you guys saw, so to this one, do we have another pair of alternate interior angles? Keegan?
No, E and A.
E and A would also be alternate interior. So we could include that in the same step here if we wanted to. So I'm just going to include that on A. Angle A is congruent to angle E because they're still alternate interior. So I'm able to kind of group that underneath the same reason, and then I'm going to mark those angles. Okay, let me get rid of my highlighting so we can kind of see what we've got here. Now, if you didn't want to use both pairs of alternate interior angles, you could have used the vertical angles that are in the picture. So if you had written down like B and D are congruent, and then you went on to the vertical angles instead of talking about A and E, that's fine too. That's actually what we did on our bell ringer today. But I'm good with what we have so far, because do we have enough to say that the triangles are congruent? What test is being used here? Good, angle, angle, side. So if I say triangle ABC, what would be the other name? EDC. Make sure you keep the like marked things together. Like A and E, both, I put 2 arcs in there, so they have to stay together in the name. Okay, now before, this is where we would have stopped, right? Because that would have been our congruent statement. We would have been done, but that's not what they're asking me to prove. They want me to prove that the sides AC and EC are congruent. Now, there was nothing in my given that allowed me to say that. Like, I don't know that C is the midpoint from the given information, so I wasn't able to mark that. I also didn't have anything as I kind of worked through my pattern to get me there. But we were able to say that the triangles are congruent, which means then everything about these 2 triangles should match. So I should now be able to add on, to finish off my proof here, that AC is congruent to EC using that new thing we talked about today. Anyone remember it? CPCTC. Your C's are every other letter. So you start and end with a C, and there's a C in the middle. Corn, potatoes, chicken, tomatoes, chicken. Okay? You'll probably hear me say that a lot.
So will it always end with that?
It will always end with that for these kind of proofs. We will always end with CPCTC when we're trying to prove that sides or angles are congruent to each other. Okay? Okay, let's do one more here. We all good on number 1? Let's go over here to number 2. Okay, and let's again, everybody write down the given. Do they have that stuff marked? No, so let's make sure we go in and do that first. So BC and DC are congruent, so I'm just going to give them each a dash. And then AC and EC are also congruent, so I'm going to give those 2 dashes. Well, we're off to a pretty good start because the given gave me 2 pieces of information. I need 3 to say that triangles are congruent, so I need one more thing. Keegan? Vertical angles. Again, I'm hoping anytime you guys see this shape, this bow tie shape, that you're like, vertical angles are going to be there, because they usually always are. Okay, so we're going to name those. How do you guys want to name the vertical angles? ACB. Good, very good. ECD. Okay, and then I'm going to mark those. Do I have enough to say the triangles are congruent? Yeah, what test does it satisfy? SAS this time. And I really liked how you guys named the vertical angles, so I'm honestly just going to use the same names for the triangles because the order of the letters was perfect there. So I'm going to say triangle ACB is congruent to triangle ECD because of side angle side. That's the pattern I see. Okay, but we're not quite done. How do we finish this off? What's my last statement?
The word.
That's my reason. What is it? Good. So there's my statement. And then what's that reason we've been talking about? Good. CPCTC. Excellent. Questions on number 2? Okay. We're going to